Yeah, hello everyone again. Welcome to the first Codementor event of 2022. We made it. Thank you so much for joining us. My name is Darren and I will be your host. So before we start, I just want to share some quick instructions. We're using Zoom webinar today instead of the regular Zoom meeting that you might be familiar with. So don't be alarmed if you can't see other people, because that's actually perfectly normal. Okay, so the most important thing here is the Q&A feature on the bottom. You can see it on the toolbar down there. So during the talk, if you have any questions, please just drop it in there, and our speaker will answer either during the talk or at the end. Something else you can do, you can also upvote or comment on other people's questions. If the speaker is busy and you see a question that you think you can answer, feel free to just comment and help answer. So we love community and interactions here. Okay, so I think that's enough of me talking. I'm going to introduce our topic and speaker. So the topic today, as you all know, is Intro to JavaScript Asynchronous Programming. Our speaker is Tapas. He's here with us, and he works as a UI architect and senior UX manager on Micro Focus. He has over 10 years of experience in JavaScript and relevant frameworks and libraries and all that good stuff. And he also has a YouTube channel with lots of great tutorials, which I'm sure he's going to tell you a little bit about today. So needless to say, I believe he's going to share very helpful tips today. All right, so without further ado, Tapas, I'm going to hand it over to you.
Thanks a lot, Darren. Hope my snap and my audio both are coming to all of you well, and we will be able to connect through. So what I'm going to do, I'm going to share my screen right away and just get me a confirmation that you're able to see the screen. Is the screen visible where you can see the slide? Okay, I guess it is. Okay, great.
Yep.
All right, guys. All right. So welcome everyone for today's session, where we are going to talk about JavaScript asynchronous programming. And there are basically a lot of motivation behind doing this talk. I'm going through that motivation first, and then we'll be talking about the actual part of it, right? So, but before we do that, Darren has already introduced me, but still, I like to write. I have launched a YouTube channel very recently where I share some content. And I also like to kind of mentor people who want to kind of get their journey started in the web development area, passionate about web development and of course teaching. That's why I'm here. And today's session is going to be in 4 different sections. In the first section, we are going to touch base about a little bit about the function and function execution in JavaScript, because that's important. And that's a precursor I see, in learning this particular topic. Then we'll talk about what is synchronous versus asynchronous, as an idea. Then we'll demystify some of this asynchronous part in the JavaScript. I think some of you called out, it's kind of difficult. It's like, fishy and things like that. So we're going to demystify that and hope that's the heart of our session today. And then I'll also leave you guys with how to continue this journey. If some of you are, starting this journey now, how to continue that. Some of you are already in this journey, like how to continue, I'll can leave you with certain resources. So that's how the session look like in the 4 sections. You can kind of keep putting the questions in the chat if you have. After every section ends, I'm going to look into the Q&A section and try to answer as many as possible. But even if we can't, there will be a Q&A at the end of the session where I'll be able to take maximum questions possible. But before we get started, I want to kind of get the stage ready with a very common feeling that all of us have about JavaScript asynchronous programming. And courtesy to this internet, for this particular awesome story. So once you ask somebody like, what are you studying? And once they reply like, okay, I'm studying JavaScript asynchronous programming, we see the feeling of somebody's face. And of course, we all understand that it's something that a bit difficult to grasp, but what we're trying to do today is like, we want to kind of demystify or break that myth that it is not that difficult. It's just like, probably how you're learning the strategy. If we change a bit, it is far more easy than what we think about, right? So that's a very common feeling. And if you have that, don't feel bad about it. I myself had that. I'm trying to break that. Second thing is a very common question. And this is mostly I keep getting from many folks who are just getting into the web development. The question is, I already know async and await, and why do you have to learn more, about this topic? As long as you are able to perform your work with async and await, you are able to debug the code, you are able to debug existing promises and everything that somebody who worked on the code before you written, you're understanding everything, and you will to answer your interviewer's question about promises, you don't have to learn. But if you want to kind of get into a situation where you want to confidently answer promises questions to your interviewer, you want to debug confidently about those promises things that somebody have written before, you got to learn a little bit about some of this asynchronous programming and how things works under the hood, right? So that's the purpose. All right, so section 1. At the start of section 1, we want to talk about function. So if you're coming from any programming language background, most of the programming language, I guess that it has functions. So what exactly functions are? If you have a bunch of lines of code, you want to logically group them so that you can perform some task over and over and again, right? You don't want to write the same line of code again somewhere else to kind of repeat, your task. So basically, you kind of put them inside the function. That's what this particular image depicts. You have the line of code, and then you're organizing them into a function. Right? That's what the function is. In JavaScript also, the criteria is same for a function. Now, in JavaScript, the functions are kind of first-class citizens. So what do you mean by that? If you open any JavaScript programming or any JavaScript file, I'm just leaving the ES6 classes aside a bit. Everything that you see is in terms of functions. Basically, you have written a lot of functions and then kind of reusing them into multiple places, try to kind of execute certain tasks. So functions are everywhere. Now you can create functions. This is an example how you will be creating the function, using the function keyword and the function name F1 over here. And inside that you are doing certain coding. You want the F1 to perform certain activity. And then finally, what we are doing over here is like we're invoking the function, right? So this is, you can create a function in JavaScript. You can assign a function to a variable. So you create a function over here. And then what you do is you are doing an assignment of this function to a variable, and using this variable, you can actually invoke this function later point of time. So function is not only that you are calling and invoking, you can actually assign that to a variable and then use that variable to invoke it. So it's powerful. One more power that we have in JavaScript is like you can pass a function as an argument to another function. Passing a function as an argument to another function. What is very normal is like passing an integer, Boolean, or any kind of data type to function as an argument and doing some computation inside the function and then return certain values, right? So that's a normal flow. But you can also do something like this. You have a function F1, and it is actually expecting a function over here, F2. Inside that, you can actually invoke F2. When you're invoking F1, what you see here, you're passing a function. That function does something. People who have, realize that they're using callback function for a while, this is something like an example of a callback, a function which is taking another function as an argument and calling the function that we are passing as an argument at a later point of time inside this function based on your business logic. So you're calling this function back at later point of time, as simple as kind of doing a callback mechanism. Now this fundamental thing we'll be using in a greater way when we start seeing some of the asynchronism, going forward. And the last thing that you can do with function is like you can return one function from another function. That's also possible, right? So here is a function I have F1. I have a bunch of code over here. And after that, I'm returning a function from here. So if I have to invoke this F1, as simple as that. If I invoke F1, it is going to return me this function, which I can actually assign to a variable. I showed you like I can actually assign a function to a variable. Once I assign that function to a variable, this return of F1, I can actually invoke this return function like this. So these things make JavaScript is very strong as a language, and the functions as a like first-class citizen, so that you can do everything possible, including functions. So these 4 usages I want you to keep in mind, because some of the examples that we are going to see today, specifically the one where you are passing a function as an argument to another function, you will be able to relate those a lot, right? So that's the purpose of it. Now, as we have seen function, and we have also seen is like how we invoke a function, like, you have the function name, then the parentheses, and if it has any argument, pass them as a parameter, and then you invoke this, right? So what exactly happened when we invoke a function, right? So that's something that we want to kind of learn. I want to introduce you to one concept called function execution stack. That's what we're going to see a little bit deeper now. So once we do, well, before we kind of get into the asynchronous programming, you want to learn anything about asynchronousness, we need to understand the synchronous part of JavaScript, how things work in JavaScript when the interpreter goes, sees every line, executes things line by line, how the things works internally. Once we understand this synchronousness, in a more visual and a pictorial way, then understanding the asynchronous is as simple as getting into just the next step, and that's what we are going to demystify a lot. So there is something called function execution stack. We also call it as call stack. So most of us are aware like the stack data structure. What the stack data structure is like, once whatever gets in first, that is something that's going to come out the last from that particular data structure. So this is where it is. So if you have a function f1 that gets inside the stack, then probably f2 got inside the stack, then f3 gets inside the stack, and then f3 comes out first, then only the f2 gets an opportunity to come out, and then f1 gets an opportunity to come out. So in JavaScript also, we have something called function execution stack, which keep track of execution of the functions, any code inside the function that executes the function itself is called function execution context. And that will be kind of going on one by one. So let's take this as an example. So now what I'm going to show you is some example through which we'll be able to understand this function execution stack a lot better, right? So let's get into some example. I'm going to share my VS Code. Please let me know if you're not able to see this. So what I have over here, a very simple example. I have a function f1, which logs f1 into the log. I have function f2 logs f2. I have function f3 logs f3. Now what I do, I invoke function one by one. What it means is like I invoke f1 first, then I invoke f2, then I invoke f3, right? Now what is the output? If I ask, I'm sure 100% you will be able to tell the output is f1, f2, f3. Very, very simple. Now, but what exactly goes in if we actually start thinking of it from the function execution stack perspective? Let's see that. I've created an image which will demonstrate that execution. Let me just try to pull that in a bit. And then we'll run this particular program to see that, okay, that is matching the output. Okay, same program over here. So first F1 invoked. F1 gets into the function execution stack. Execution over comes out. F2 it gets invoked. F2 gets into the function execution stack, come out. F3 gets invoked. F3 gets into the function execution stack, come out. You will see this as it is a GIF file. You will see this repeating. So F1 is again, it will come because it's a GIF file. It will repeat the whole scenario once again. So the point over here is like it is executing things line by line. It's this F1 first gets into the stack, out of the stack, then F2 out of the stack, F3 out of the stack. Now, let us take another example, which is little bit trickier, right? So let me open up that particular example over here. Take this example. Almost similar, but a little bit changes. So in this case, what we have is like, we have F1, one function, console.log F1. F2, again, console.log F2, but it calls F1, all right? Then we have F3, console.log F3, it calls F2. And then finally, we are calling F3. So what's the output that you think it is going to be, right? So F3 first gets, in the global execution context, we have only F3. So first F3 will run. F3 will print console.log F3 into the console. Then comes F2. It will print probably F2. Then comes F1. Then it's print F1. Now, how this thing happen in the execution stack? How execution stack will continue executing this thing. So let's see that. I have a similar kind of image again, where we'll be able to see this. I'll just pull it up, side by side. All right. So F3 first gets executed. F3 goes inside the stack. Function goes inside F3, found F2, put it into the stack. Inside F2, it finds F1, put it into the stack. Very interesting scenario. Now, F1 gets executed, goes out of stack, then F2 goes out of stack, then F3 goes out of stack. Now you understood that thing. So how this function execution stack or the call stack works, it finds a function, put inside the stack, start executing it. Inside that, if it finds second function, it will put that function inside the stack, find executing it. Once the execution is over, the control comes back to the first function, executed it, bring it out of the stack, and then the stack becomes empty. This whole process of executing things one by one, it's always happen in the synchronous way. This is the synchronous nature of JavaScript. So we have not stepped into asynchronous at all, but this is crucial and very, very important to understand how call stack works, how execution of the function works in the stack before even we start talking about the asynchronousness, right? So I hope this portion is kind of clear to you now. You understand, like, how things are kind of working inside the call stack and the function execution stack before we kind of move further. Coming back to the PPTs. So this is the same thing that we have seen, the execution F1, F2, F3. So I'm just passing this, this is the same thing we have seen just now, F1, F2, F3, passing this one. All right, so before we go to the next section, what I want to just take a small pause, and I want to understand, like, if any of you have any questions, so if you can chat, put it into the QA section so that I can take it up. At this point, I don't see any open question. So is there anything in the chat as such? I guess no. Okay, so I don't see anything in the open question area. So probably I'll move on to the next section. And then in case if you have any question, please go ahead and start typing in the QA, and I'll come back to again when this particular section gets over. So in this section, the next section, that what we're going to talk about is synchronous versus asynchronousness, right? So this is going to be a bit interesting. What exactly asynchronous mean, in the real life also? It probably means there's something which is not happening or occurring at the same time. All right, synchronous means it's like I have something, and after that the next thing happening, after that the next successive thing happening, and so on. The things that keep happening. But when you're talking about the asynchronousness, is like it is not occurring at the same time, right? So there is no guarantee that it will occur in the same time. And why? Because once you are performing certain operation, for example, you are fetching some data from the server, like you are fetching some data from file system, or you're getting some data from any other places. You don't want, your code execution to be halted. You don't want your code to look like, application to look like that is completely frozen. You don't want that. So that is the reason there is some amount of asynchronous, or the mechanism handling is required in the language. Yeah, of course, you do not want JavaScript engine to halt. Now, there are primarily two trigger points that we'll be talking about today for the asynchronous programming. The first trigger point is something called browser APIs or the web APIs, right? We'll talk about a bit over here. We'll take some examples as well. And the second thing is, of course, called promises. And of course, we'll talk about async await a bit. I know that async await is very, very famous, and everybody loves about it. So first in the browser APIs, and then promises. We'll understand promises, and then we'll get into the async await part, right? So let's get into browser APIs. So here, what we'll do is, like, we'll try to do through some coding, right? So let me just start putting this and run it with live server so that I can show you some code over here. Okay, it is running over here. I'll bring it in just a second. All right. Yeah. Okay. So I hope that you're able to see now the code, plus side by side, if I execute certain code, what will be the output, and I'll be able to probably write certain code and execute also over here. So I'll be able to show this side by side. All right. So in the what exactly the browser API or the web APIs, what are some of these things mean? So for example, you have a button, right? On your web page, and you click on that button. What happens is, basically, usually you will be writing something called a click handler or a click listener, And click handler, what it does is basically once you click on a button, what you want to do on the click on a button, it could be printing a message, go to the server, fetching the data, or whatever, changing color of something. The action will be performed inside a function in the that particular click handler. So the browser API is nothing but the click handler is one example. A very famous example that we probably all of us know is called set timeout. Set timeout, basically you want to execute something with certain delay, or set interval, you want to execute something periodically in some delay, in some kind of period manner. So these are various different functions available in JavaScript itself, the programming language itself, which allow some sense of asynchronousness. So that is one place we realize it. So let's try to take this one. Let's try to create one, like say function, say print me, and then what we'll do is like we will do like console.log. We'll say like print, and if I just do print me over here, what I'm expecting this print to be printed over here. But if I use set timeout, how set timeout works basically? Set timeout first take the function that it wants to execute. There we are passing this print me, and then it takes a delay in milliseconds. So 2000 milliseconds is basically 2 seconds. After 2 seconds, it's going to call this function. So it will have a delay of 2 seconds, and then the print comes to the picture. So you saw that there is a delay of 2 seconds. You'll see 1, 2 seconds. Yeah, then the print come into the picture. So this is a sense of asynchronousness, right? It is not happening something very, very immediately, right? So this is one example. Like now, what we'll do is like the browser APIs or this kind of set timeout or the click handler, when these things come together with your normal code execution of the functions, we feel a bit lost. That's the time we start thinking that things are probably a little bit trickier or a little bit difficult to comprehend, right? Let's take an example, and I want you guys to answer like what will be the answer of this particular code. I'm going to copy paste this code over here. This is the code. Print me, console.log print me, function test, console.log test, set timeout print me 2000, and then the test. Whether the output will be print me followed by test or test followed by print me. What would be the answer? Let's try. So I have test, and then after 2 seconds, there is a print me. This is kind of pretty obvious because I'm printing the test immediately, and then I'm giving a delay of 2 seconds, and then I'm doing the print me. Now let's make it a little bit more trickier. I don't give any delay. And then that's where the confusion become bigger. I don't give any delay and I print it. So what exactly am I expecting? Am I expecting print me first and then test, or am I expecting test first and print me? So if you are expecting print me first and then test, you're going to be disappointed even if there is no delay, because test is going to get first and then it is print me. Now we will introduce you to the first thing of asynchronous programming, like how things are going to take place, what is this callback is, and there's something called task queue, callback queue, all this thing. And then we'll come back to this function again, this particular code again, and I'm sure that you'll be able to answer, understand like why exactly the flow is happening in this way, right? So let's do that. So I'll open up a simple example. This is the example. What I'm doing here, I'm doing a function f1, console.log f1, straightforward, function f2, console.log f2, and then I have a main function where I'm doing a console.log main. I have a set timeout, the browser API, which executes this f1 function with 0 delay, no delay. Then I'm executing f2, asynchronous function, and finally I'm executing the main. So we'll understand like what exactly it happens, but we'll understand with a diagram, right? So first I'll pull that diagram for you. Okay, so this is pretty important for us to understand. We have seen this portion already. This portion is called call stack. It means when I'm start executing this program, First, main will get into the stack, and then main will get the console.log. It will get the console.log into the stack. Like that, everything that is there in the code, it is going to get into the call stack. But we are seeing two new things here, right? One is a placeholder for browser APIs, and then we are seeing a thing called callback queue or the task queue. I like to call it as callback queue. Task queue is somewhat little bit difficult to remember. So what exactly these things? So let's see with this code. First thing the main happen. If the main happen, it will go to the call stack straight away because it's a function. We have learned every function execution when it happen, it goes to the function execution stack or in the call stack. Now, after main comes into the call stack, main will start executing. The first thing it sees when the execution thing is console.log main. Okay, not a rocket science, execute main comes into the log. Then what it sees something like a browser API, which is like set timeout. Now, set timeout is given by JavaScript itself. It's a JavaScript API, and JavaScript engine recognize that. So what it does is like it sees like what is passed into the set timeout. Whatever passed into the set timeout, it's called a callback. So whenever there is a callback, things is there. This puts this particular F1 into the callback queue. Doesn't do anything, and then proceed. Okay, proceed to F2. It finds F2, put into the call stack, and then F2 gets executed. Now, then F2 comes out of the call stack, main comes out of the call stack. Once it finds the call stack is empty, then it will look into this callback queue that if there is any function, and then pull that function to the call stack and then execute. So the mechanism through which it is done, or the code or the program that make these things done, like put everything in the call stack, look into the callback queue, and then putting from the callback queue to the call stack, it's called event loop. So if you heard about event loop before, and if you are confused like what exactly it is nothing like, it's like an algorithm or a program that is there in JavaScript itself. Its only job is to look into, is my call stack empty at any point of time? If my call stack is empty at any point of time, look into the callback queue. If there is a function, pull that function to the call stack, execute, job is done. We have seen how things works in the call stack. We have seen how things kind of goes one by one in the call stack. So if something moves from the callback to call stack, it's just like another normal function. Now the question is, how is this particular function gets executed? Okay, fine. Let's see this flow live, and let's see like how this thing's executed. It will be exactly like how I explained. First, main goes inside the call stack. Then console.log comes into the picture, gets executed. Then it's a set timeout. All right, it's a set timeout, web API having F1, put F1 in the callback queue, won't execute, then goes to F2. F2 gets executed. F2's console.log gets executed. F2 comes out, main comes out. Now call stack is free. Even if we'll put F1 over here, F1 having console.log, it will execute. So this is the reason the output will be main F2 and then F1. Output will be main F1, F2, because we are JavaScript engine parking this particular F1 execution in the callback queue and executing only when the call stack is free, because it's a browser API and it has the asynchronousness along with it. Let's see this once again. Once this particular iteration, the GIF iteration gets over, we will see this again from the beginning so that we understand it very, very clearly, right? Okay, F1 console.log F1, it goes off. Now we'll start back again. All right. So first thing that goes inside the call stack from the global execution context is main. First line is console.log main. Great, print it out outside of stack. Then set timeout, special thing, treat it as a special thing. Put F1 over here because it's a callback, put it in the callback queue. Then F2 as usual, F2's console.log is F2. Print F2, F2 over, then main over. This is free, put F1, execute F1 because F1 is having a console.log F1. That's all, boom, done, right? So this is how the cycle goes. And if I bring back this thing and just change my index.html to print this, take this particular stuff, /03 browser API and save it. Go to 03 browser API and bring it. All right, so let's execute this. Okay, so main, we have main, then we have F2, I think it is executed, and then we have F1, right? So this is what that execution is happening. So I hope that this is clear to you, and this is the time that I can take a pause again, and I'm going to the Q&A section and try to answer certain questions. Can we explore execution context, both global and local, also call stack in Chrome DevTool and the Chrome browser? Okay, so exactly the way that we are performing over here, we won't be able to do it, but there are plenty of tools, and we'll be talking about some of these tools at the end of the presentation. We'll be talking about, I'll show you some of the tools as well, where you will be able to see that, people have created those tools. If three functions are placed inside a function call stack, are you saying the last in first out function to be executed first before the next one? Yes, that's exactly that we have seen over here. So it is having F3, and if you like, for this thing is like, if you change it like inside F3 for F2, inside F2 for F1. So first thing is getting executed is F3. Preventing this one, the execution is not over because it encountered an F2. So it will go and try to execute F2. Print F2, execution is still not over of F2, and F3 because it encountered F1, it goes to F1, print this one. Now execution of F1 is over, take out of the stack, control come back to the last one, which is F2, execution is over, take out of the stack, control come back to the F3, execution is over, take out of the stack, control stack, the execution stack is empty. So this is how the stack things will happen. All our browser web APIs are asynchronous. No, not everything is asynchronous, but most of it, like any click handler, if we take where you have the callback functions, then you have the set timeout, you have set interval, but that list is basically purely asynchronous. Now there is something called, say, resize observer, like you want to resize certain things on the web UI, and based on that certain impact, certain effect will happen. You want to record a speech, web UI speech, or you want to do a stream from the video. Most of it are asynchronous mechanism, and that's how it should be basically. Could you explain the last part of the execution, please? Okay, I'll come back to that. Why is called browser API? Is it only for the browser and not for the server? Exactly, good question. So initially, the JavaScript was a programming language for browser. Right, it's a brain for the browser programming language before Node came into the picture and you started using things into the server side. So the functions like the set timeout, the functions like some of these things are exclusively that works in the browser. For example, media streaming, those APIs are exclusively for browser. Now, some of the things that works in the browser, for example, set timeout, set interval, is also works in the Node environment. So I cannot exactly say that it is like browser APIs only, but at one point of time they were browser APIs only, but they have their presence in the server side also. But there are certain APIs which are still browser only. I just stole their name, like the media streaming, speech thing are completely available in the browser. Things like console. Console is, by the way, another API, right, which is available in the browser and also in the Node environment. Okay. Why do you have to over the function after calling? I didn't get that question. So please clarify that question. I'll come back to that. What are some types of functions that may go to the callback queue on the asynchronous function set timeout? Exactly. Very good question. So I have showed, like, in JavaScript, you have a function which can take another function as an argument. Now, if you just do that, take a function, put another function as an argument, and execute the first function, that is not going to go into the callback queue. That will execute in the normal callback stack itself. But if the callback comes into the consideration of things like set timeout, your browser API, web APIs, and we'll be seeing promises, just in a while, it will go to the queues, not necessarily on the callback queue. We'll see some other type of queues also very soon. If the function execution time is much more than the timeout set, how would the callback works? Okay. Function execution times, it is more than the timeout. There is nothing called timeout. What exactly set timeout is doing, it will execute the function after certain time delay. So for example, if the function execution say 3 seconds and you have given a time delay of 5 seconds, what will happen is, like, after 5 seconds, this function execution starts, which will take 3 seconds. So ultimately, this particular function to get executed and produce a result to you have waited for 8 seconds. So this is how it is. Okay, I skipped one question, I think. Okay, so I have to click, I think, answer live. So can you explore the context of global? This is done. This is done. Could you explain? Okay, last part of the execution, please. I think this is what the last part was, where you have multiple functions where the functions can be kind of stitched inside one or getting called inside one. Always look into the fact of like where the execution line by line is getting over. In this case, again, when F3 occurs, it is coming here, but here it is hitting another function. So it means the execution of F3 is not over. It is going to quickly switch to F2. That's what's going to happen. It is going to be here. Again, coming here, it sees another function. That means it has to execute another function. Same stack is going to use. It is not going to create another stack. And the same stack that F1 is going to get into. Now in the F1, after console.log, doesn't have anything. Means execution is over. Come out of the stack. But where the control comes, where the control was last time before it considered F1, that is over here. That means this line is over. Nothing is there after this line. If there was another console.log or another something, that would have got executed, but nothing there. So it will come back to again with the same philosophy where it left it here. Okay, after this, nothing is there. Everything comes out of the stack. So that's how it is. All right. All are done, I guess. So I will just move. Okay, so there is another question. Let me put it in a different way. A callback was supposed to be executed after a time delay of 2 seconds. At that time, some functions are still being executed in the stack. It will wait. How the callback handle that question, right? So if some functions are getting executed in the call stack, everything and anything that are there in the callback queue will wait. So we'll understand this particular algorithm once more. So what we'll see, like this, let's consider this is the program. This is called event loop, may not be presented very intuitive way. Now this particular event loop is job, the algorithm's job, only job is to look into when this call stack is empty. That means nothing is executed at this point of time. When this call stack is empty, only that point of time, it looks into this callback queue or the task queue, take one task and put into the call stack, execute that, and the job is over. That's how thing is. So yes, it will wait if the call stack is not exactly empty, right? That's one of the reasons that you should not be relying on set timeout in a kind of function in a great way if always if you're not very sure like what exactly you are doing, right? So with that, I'll just move to the next section of the thing. Let me just pull my presentation up. It's called promises. Okay, so with promises, what we'll do is like can I guarantee the set timeout? Can I guarantee the same time set time delay? I'll come back to this question after this section. Okay, so we'll talk about promises a bit. What exactly promises? So what I have seen, over the period of time is like the understanding and promises goes too much into understanding the signature of coding promises, writing promises, and that is where I guess the most of the fear from understanding promises comes from. So what we'll do is like, let me kind of articulate that with some story about promise, right? So this is a story that, a kindergarten story that most of us have heard as a rhyme. Is called Jack and Jill went up the hill to fetch a pile of water and Jack fell down. That is the story. So let's see, Jack and Jill, they went up the hill to fetch, a bucket of water, and down the hill, their grandparents are waiting, when Jack and Jill is going to come back with the water. And Jack and Jill actually promised their grandparents that they're going to come back with the water. So that's a promise that they're given to the grandparents, and grandparents are waiting on that particular promise. They have gone to fetch the water. Remember this terms, fetch, promise. Now, two cases can happen. One case, they fulfill the promise. That means they come back with the water, and then the cooking happened. It's a happy family. Everybody is very happy. Or while coming down, the actual rhyme thing happened, Jack fell down and broke his crown, and they lost the bucket of water. And unfortunately, there is no cooking that day, poor family suffers that day. We don't want that to happen though. So in the real life programming, the promises works exactly the same way. In the code execution, line by line code execution, there is something which is waiting for certain things to either fulfill or come out with an error. The certain things could be as simple as fetching certain information from the database, fetching certain things from the some server or some file system, anything that is asynchronous, anything that you think that it is not going to happen in the same sequence or the same time. That's the time you will be going for writing promises. Now, when we write promises, The promise is a special object in JavaScript. So you create with new promise. We'll see some code now. What it takes basically, it takes an executor function. The executor function has two parameters called resolve and reject. Whenever the promise actually fulfilled is resolved correctly, we will call resolve to notify the caller saying that, hey, I am done. Now it is your job. How do you want to kind of use this output? If there is a problem, it's called reject to say, notify the caller again saying that, hey, I could not do this. Now, can you please proceed with whatever the error that I'm going to give you? Exactly with the same story that we have. This grandparents are somebody who was the caller program, who actually created the promise and waiting on the promise to either resolve or reject. Jack and Jill, who actually went up the hill to fetch the water, they are actually, the task they're performing is nothing but the executor function that we pass into the promises. Once it resolves, their grandparents, the caller gets the water. Once it doesn't reject, they basically fall down. They don't get the water. As simple as that. So that's the story. Now, if I see that in terms of coding, how do we find this? Let's go to this particular code, right? Let's take this code alone. Let's not see anything else. So what we have done here, we have created a new promise. Promise is a JavaScript object again. And what we pass to a promise, only this portion till here, is called an executor function. This executor function will perform the task that what you are supposed to do. Basically, you are going to fetch certain things from the database or server or do whatever. This is where you are going to do this. Once you have performed this task, what you're going to do, you will do a resolve or you will do a reject. Once the resolve or reject happen, anybody who is actually listening on this promise or basically want to get notified on the resolve and reject, they will get notified saying that, hey, something happened. Either I am getting the value or not getting the value. Now, if I have written this code in this fashion, it may be a little bit tricky, but if I just change this code a little bit, like say, promise equals to promise, and I take this guy away. So this is purely the place where I have created the promise. Now, anywhere where the promise object is available, I can actually do promise.then. And what exactly the then is a handler function of promise, which gets called only when a promise is successfully resolved. And if the successfully resolved, I get this value. This instead of resolve, I can actually call it a value, any variable name, and I can do anything with that value over here. So it means that if I resolve with water over here, I can get the water over here and I can cook rice over here. If I do a reject, then instead of then I will do a catch. Inside that I will catch that error that, okay, they fell down. There's no water, probably we have to get them, from the hill and take care of them. So this is basically how the promise works. One place where you will create the promise, another place you will be listening on the output, like once the promise execution, anything inside that executor function gets over, basically you will be doing some work over here, in this place, you'll be performing some work over here. And then that output you will resolve with, so that whoever listening on this promise, once this resolve is done, they will get the value over here and they want to do anything and everything that they want to do with this value. All right, so this is how the promise thing works. Now, two things we have seen so far. One we have seen called function execution stack, and one thing we have seen that callback queue. And of course, we have seen that when the callback queue happened, it mostly handled the mechanism where asynchronous callback, like the browser APIs, that sort of callback that it actually non-promise basically callback it handles. But with promise, we will introduce to another concept, probably the last concept of today, which is called microtask queue or the job queue. If there is a microtask, all this confusion is there in the terms. Just remember them as a task queue and job queue, or the callback queue or job queue. I think that should be enough for you to understand. So let me kind of bring in another image so that we can actually explain like what is the algorithm or what is the thing that event loops takes into consideration when it not only sees a function that gets executed, not only sees a set timeout like thing that gets executed, but also sees a promises. How does it going to treat this? For example, if I ask, what is going to be the output of this particular function? Is it going to be main F1, I am a promise F2, or main, maybe I am a promise F2 and F1, or main F2, F1, I am a promise. I don't know, just guess it. And but once we just guess something, and you can actually reply also in the answer. But once we see like the algorithm, we'll see like, how exactly it works. So the algorithm. Now what we see, apart from call stack and the callback queue, we also see something called job queue. So we have learned that when the function gets executes line by line, all this execution that happens in the call stack, whenever there is a set timeout or related browser APIs and it has a callback, that callback functions goes to the callback queue. If there are multiple such set timeout, there are multiple callbacks are there in the callback queue. Now, what happened in the job queue? What happened in the job queue is basically whenever it encounters a promise, and if you just see closely, the promise object takes another callback function, another function, basically it is a function, right? This is an executor function. And after that executor function gets executed, whatever has to happen, that is a callback function. Like this callback is like, do something with a value. So that has to be executed somewhere, right? Once you get the value, something has to be happened. So this part needs to be parked somewhere so that whenever this promise gets fulfilled successfully, this part, whatever is there in this console.log, this can be executed. We will push that back into our job queue, right? So we'll get into the job. I'll get this one. So we'll get into the job queue. So call stack, execute things line by line as usual. For the set timeout related browser APIs, callback will come to the callback queue. For promises, the callback comes into the job queue or the microtask. Now, think about the situation. Basically, the same situation, whatever we're seeing here. We have things in the call stack. We have things into the callback queue. We have things into the job queue. How things are going to happen, how the synchronization is going to happen. That's where this particular event loop algorithm comes into the picture. The first fundamental that don't take anything at all from the callback queue or job queue until you find the call stack is empty, remains same. There is no change in that. But there is one thing that comes into the two things that comes when the job queue come into the picture. Anything and everything that are there in the job queue takes a higher precedence than the callback queue. So it means at any situation, if I find the call stack empty and I find one function is in the callback queue, another function is in the job queue, I will pull the job queue one first, execute, and then I'll come to the callback queue and then I'll see it. So if somebody asked me like, the set timeout, the time, exactly time I'm giving, am I sure that that is the time after my function will execute? No. It depends on many circumstances what you have into the code. That's why you should not be relying very heavily on a function like set timeout. Okay, so it means that if I have these two things, I'll pull from job queue, put in the call stack, execute, call stack is empty. Then only I'll come back and see, do I have more in the job queue? If I have more in the job queue, again, I'll pull from the job queue, execute it. I'll ignore callback queue until I see job queue is completely empty for a pass. Then I'll come and see the call stack is empty. I'll put one callback, execute it, and the algorithm continues. Okay, so these two additional things, like apart from seeing the call stack is empty and pulling from the callback queue and the job queue, what we also need to understand very clearly is like job queue gets a higher precedence than the callback queue. And once you get everything from the job queue, then only you will kind of get into the callback queue and do something. Why don't we see it in an example? The same example that we'll be kind of seeing over here, right? So we have main. So console.log main, of course, the main, gets executed. Then it set timeout. F1 goes into the callback queue. If you have taken the screenshot of the image that I was showing, great, or try to visualize it in your brain. Like you have a callback queue, the F1 goes into the callback queue. Excellent. You have a promise, this anonymous function gets into the job queue. Awesome. Then you have F2 gets inside, it gets executed. F2 gets executed. Now you have your function execution stack free. You have F1 in the callback queue. You have this anonymous function into the job queue. So what event loop will do? Event loop will first take from the job queue and put in the call stack. So first this guy gets executed, gets over, then F1 gets executed. So your output will be always like main, F2, I am a promise, and then F1. F1 comes last, even if it has zero delay. That's why don't rely on set timeout much, right? So let's see this, this particular things happening. All right. So I'll just pull this guy, that image, give it a second. Okay. All right, call stack. First thing, main come into the picture. Console.log main come into the picture, gets executed. Set timeout, same like before. WebUI. So F1 will come to the callback queue. Excellent. Now the anonymous promises comes as the step-by-step execution. Then F2 comes. F2 gets executed because console.log gets executed. F2 goes out. Main done. Free. Among this, now first job queue gets into the picture. It has the I am a promise, gets executed. Then F1 gets into the picture. F1 is having console.log F1, then gets executed. So that's the sequence that you need to remember, my friend, because if we don't get this sequence correct in our mind, then these are the trickier questions basically, even if we don't like our interviewers ask, and then we will see like there could be some kind of issues and problem. Also, when you're debugging a code such like that, where we're anticipating that like set timeout is 0 should kind of happen before then this particular thing, you may not see it happening in this way, right? Now I want to show you one more quick example, this one, right? And we'll come back to this one. I want everyone in next 1 minute to look into this example that I'm going through one by one and start typing what you think the answer would be, or at least try prepare yourself like what would be the output of this program. Let me go through it. So main, first is main. Main comes here. So it's a console.log main. Then it says to set timeout. One with F1 at 50, F3 after 30, okay, milliseconds. Then it has a promise. Promise does like I'm a promise. And then it has another promise. Then it has F2. Now, if you're saying that, in any kind of coding challenge or wherever you go, you will get this kind of questions to answer, right? So how do you do it? Now things are very, very simple. What I'll do, I'll bring that picture again in front of you, the job queue thing, so that, it will be pretty easy for you. Just let me pull it. Okay, let's think this one in the job queue perspective. Okay, so how does this things gets worked? So first is first is main, right? Main gets into. It says first line console.log main. It prints main into console. Then set timeout F1 after 50, set timeout F3 after 30. F1, F3 both goes over here. It says that, okay, F3 I have to execute after 30. That means F3 I have to first put into the callback queue. Then F1 I have to put in the callback queue. So callback queue now has F3 and F1. Then I have two promises. Both the promises callback or here as an anonymous function. Then I have F2. F2 also gets executed. So first is main, then prints F2. Now call stack is empty. But in the callback, we have F3 and F1, and in the job back queue, I have two promises. What will happen? Our algorithm says, once the call stack is empty, look into this callback queue or the job queue. If you have everything or anything in the job queue, bring them one by one into the call stack. It's a queue, right? Queue is different than stack. It's like first in, first out. So whoever first in, they will first go out. This is a first in promise, will go out and execute. Then this promise will go out and execute, because once you're in the job queue, you will make the job queue completely empty before you go to the callback queue. Now job queue is empty, call stack is empty. You come to the callback queue, you see F3 followed by F1. You will take F3 executes, then you take F1, then you execute. So your output is going to be main, F2, I am a promise this one, then I am a promise after this, then F3, then F1. So always think through from the fact of how this callback, browser APIs, call stack, all these things are kind of work out together. What is the algorithm, and through that algorithm that we need to kind of take the call, right? So I think that while I was explaining, I've already got into my section 3, where I was demystifying these promises and all of that stuff. So I'll take a very quick pause and I'll try to get some answer to these questions. Okay, how far I have answered? Let's go back. Top. Can you explore the execution context, both global and local? I think we have answered this one, this one, this one, this one. Shall I cut to the set timeout? Yes, I've answered this. Why do we finally we use finally in promises beside the catch. Okay, good question. So the finally is guaranteed to execute irrespective of whether you are doing a resolve or reject. Finally, we do mostly for a few purposes, like you want to initiate certain things or you want to say clean up few things. In our regular programming, web programming, when you are making asynchronous call, by the time you are actually getting the response, you might want to show a loader. And once you get the response and the thing that you want to render into the web page, you want to kill that loader. So those are the work that you do in the finally. So in the finally, you can actually initiate certain things to show, and after that also you can kind of clean up. Database connection could be one thing. You open a connection, you can open a connection in the finally, you can close a connection in the finally, which are really not dependent on what exactly you are going to respond from the from your resolve or reject, but some generic task that you want to perform, you'll put it in the finally. Then okay, shall I conclude? Yes, answer. So job queue. Okay, so job queue comes to the existence when there is a promise, right? Why does it have a higher precedence of the callback queue? Because the programming language, the JavaScript programming language has built the algorithm in this way. That the vision is most of the time when you are actually making an operation, even if you have a click handler, which is a browser API callback. Even in that callback, most of the time the operation that you perform is like fetching certain data, if you're doing the fetching certain data. So of course, instead of executing the callback and making that callback successful, the first thing probably you need to see what is the purpose of that particular callback, which is like fetching the data. So anything and everything that you do in the promises is mostly that sort of work where the asynchronousness and the result of the asynchronousness is going to decide how your application is going to respond further. So you want that particular stuff to happen well before any other browser related APIs that is happening kind of pretty locally. So that is why it is the program itself the algorithm itself is such that it is given the higher precedence. Last part of the executor function is part of the queue. Okay, please mention the tools. Okay, I'll mention the tool at the end. Don't understand why F3 and F1, the JS read from the top to bottom. Yeah. So so I think we are talking about that F1, F2, F3, JS read from the top to bottom. So that particular function. So you don't have to think like when function are defined. You have to think when functions start execution happen. So all the functions are going line by line, line by line, line by line. But the first execution of that happen is like at the F3 level. And once that execution happened in the F3 level, it gets into the F3 and see if there is another function execution. Basically, function execution happens when you invoke a function, not like when you define a function. So the everything that comes into the call stack, it will happen only from the function execution side. Though the code is reading one by one from the top to bottom, but the top you might be just defining the function. You're not executing yet. When you start executing, that is when the call stack execution comes into the picture. The time set. Okay.
Yeah, sorry, Tapas. I was wondering if you still have other concepts to go through, because it seems like we might unfortunately not have enough time to go through all the questions because people are asking a lot of great ones.
All right. Sure. So let me just check back just a second if I have anything else. I don't think I have much slides left after this. Yeah, it's really not much, after this. I just wanted to kind of get through the resources, talk through the resources and some of this, visualize the tool and things like that. That's what we're going to do, right? So that's fine. The last section before I kind of come back to the question answer and the tools is so how to kind of build from here. So we have got the concept of how this call stack, how this, the callback queue and the job queue kind of come into picture, what gets precedence, over each other. But, this understanding might make you feel something like this, right? I don't know what kind of emotion goes inside your brain now, but first time when I encountered, there are a lot of such emotions that went in my brain, and then how slowly it's like I was translating most of them to a happy emotion is just by doing practice. So you got to go back, practice, and relate whatever you have learned with this, whether the output you're getting is kind of matching, like, what are the concepts that you understood. So these are some of the resources that I have put over here, and you will get this PPT also, so you can see, the Lit Code Hacker Rank, coding game, big front end are having excellent promise async await related questions, which you should attempt after this and try to see, like, how are you answering them. I have created a YouTube playlist on the JavaScript async programming. The first session of that particular playlist, you will find almost similar to whatever we have covered today, but it has more other videos like, async await, and I think you can catch up with that. And then I've created one open source GitHub project called Interview Ready, which is also having few question answer with some started concept, explanation. So this is the practical resources that you need to look into. I will show a few tools. So one of this is, it's a little bit hard to bring things from one monitor to other. Let me see, it's a bit slow. All right, yeah. I like this one, JavaScript Visualizer 9000. I don't know why the name is like that. This is a good tool where you can actually see some of this thing happening, quite real life. So if I take, for example, this guy and paste it over here, and first I run it, it will take some time to run. And then what we'll do, you can actually do a step. So see here, the first step is main, because we will first call the main, right? Execution matters, not the definition. So why it is starting from here? Okay, so when I call main, the first thing is happening is the console.log main. Then comes a timeout. So F1 goes to your task queue. F3 then goes to your task queue. But which one has to come out of the queue? Of course, F3, because it has a lesser time. Then your first anonymous, the executor function. Somebody asked what happened to the executor function. The executor function first went. Then, after executor function, your microtask queue got that, what happened after the promise execution gets over, basically the then part. Then the next promise comes into the picture, and then next promise then part gets into over here. So this is the stage that we are in right now. Now, if I just do next step, F2 will come and executes, right? Now my call stack will be free slowly. If you see, call stack is free, right? Now among this, this is going to get higher precedence. Okay, done. I have a promise. Then first all the job queues, then only task queue. Remember, this guy gets executed, done. Then from the task queue, F3 comes, because F3 having the lesser time delay. Okay, done. Then F1 comes into the picture, F1 executes. So please use this tool as much as possible. It doesn't work well with the async await keyword yet, but apart from that, it works superbly with many other stuff. So I'm sure that you are going to, like this one a lot. And the final thing that I have, in case it is important, you can actually reach out to me. I'm sure that this is a 1 hour time is not, very much to kind of cover a lot of stuff, but I would really, really be happy if you DM me on, say, Twitter or LinkedIn, wherever you are. And if you have any additional questions after you go through this recording again, or go to the playlist again, or you are, struggling for certain question answer, considering my bandwidth, I would always love to help you to understand this concept the best way possible, right? Now, Darren, over to you. Can I take a few more questions that are there in the question answer section, so that with that I'll probably be able to touch base some of the items I've discussed already, or how do you see it?
Yeah, I think because of time, I think there are so many questions. Thank you all for putting all your questions in there. But yeah, I think just out of respect for everyone's time, we can wrap up the event. And I encourage all of you just follow Tapas on his social media, and you can also put in the questions on the event discussion page. Like Tapas's his social media information is also there. So yeah, and oh, by the way, this session is recorded. So next, I believe it should be next week sometime, we'll put the recording up. So if you want to come back and review some of the concepts, I'm sure that would be great. All right, so let me just make a quick announcement before we wrap up. Let me share my screen real quick. Yeah, I just want to let you all know that we have an event next week. It's actually happening pretty soon, but it's called Get Hired as a Developer, Tips from a Technical Recruiter. So Jeff, he is the Senior Recruiting Manager at ARC, and he's going to share some of his tips from the perspective of a recruiter. So I think it's going to be really interesting. I hope to see many of you there. I'm also going to put the link in the chat, so you can have easy access there. All right, so I think let's put a wrap on this event. I want to officially thank you, Tapas, for taking the time to share with us today. I know that this is a big concept, but I think this is an intro, and you just did a great job explaining and demystifying some of these concepts. Yeah, so feel free to, like I said, feel free to leave questions on the event page or reach out to Tapas directly. Yeah, and I put the links in the chat for event page in next week's event. Yeah, so that is all. And thank you so much, everyone. Yeah, and Tapas, is there anything I just want to ask if there's anything that you want to add or any encouragement that you want to give to everyone before we end.
Yeah, sure. So what I'd say is like this concept is just the start to learning. It is a bit hazy, but once you kind of break it like onion, right? One pill at one time, you will actually get to the crux of it and you will understand it, right? I'm sure that after this session, you will at least get some clue of it. Please go through the playlist that I have created in my YouTube, go through it. And then if you have any question about it, let's take it. You know, I want you to understand and I want you to learn, and I'll make sure that you learn it. Thank you.
All right, thank you so much. And thank you all for joining us today. I hope to see you all soon. Have a great rest of your day, everyone. Bye-bye.
Bye.